Okay, so number 15, I always think about one-to-one functions as a graph. So if you remember back when we did one-to-one functions, I believe it was section 5.1, if you wanted to go back and look at the video, but it was one of those where you had to do a vertical line test and a horizontal line test. So if I had a graph, let's say I look at this one, vertically, it's only touching that graph once. And horizontally, it's only touching that function once as well. So this is a one-to-one function. You could do the same thing with like a quadratic, for instance. So let's say I had something that looked like that. My vertical line test passes, it's only touching it once. But if I do a horizontal line test, it's touching it twice. So a quadratic is not a one-to-one function. Okay, so in this case, I immediately marked out that x squared because of this case up here I just talked about. Definitely that's not one-to-one. The other two, this one I knew looked like this. It's a square root function, so they always kind of have this same shape. This one I was kind of like, I don't think it's going to do that, but sometimes there's some cases where you have something that looks like that. That's a log function, and in that case, that's not one-to-one. So I wanted to check this one just to be sure. So I plugged in some values, and it looked to me like it was going to be basically like this. If I sketched the graph, that's what it was going to look like. So these two were the two that came out. Now, when I plugged in points for this one, I plugged in values for y, and I remember this being kind of an issue on one of our tests, because when I rewrote it, the base was 2, and then my exponent is f of x, or I put y, and then it equals x. So knowing to rewrite it like this is one thing. Then once you have it rewritten like this, then it's much easier to plug values in right here than it is right here to solve it. So if I plug values in here, I can just say 2 to this exponent. What do I get? So that's what I did. I said if this was -2, that gives me a 1/4. If this was a -1, that gives me a 1/2. If this was a 0, it gave me 1, and so on. Then I looked at that on the graph. So that one came out okay as well. So C was my answer choice because it was just 1 and 2. Okay, number 16. This is a formula you need to memorize. There is a problem just like this on the test. So I want to make sure that you remember this formula. So this formula gives me, here's my population, my total population that I'm wanting. This is my initial population. So they call this P naught, which is my initial population, which in this case was 260. And then e to the RT is e to the rate times time. So in this case, that was 0.14 times the time I didn't know. So I plugged those values in. I went ahead and divided by 260, which came out nice and pretty. It does on the test as well, so that's good. Then I had to figure out, okay, how do I rewrite this, this equation that has this e to some exponent, right? Well, that's where natural logs come in. If I take the natural log of both sides, that gives me natural log of 500, and then this side is just 0.14t. So then I was able to get this as a decimal, which was about 6.215, and then I divided by 0.14 and got this. So what this tells me is how much time had went by. So time going by is about 44 years. So I rounded down because this was not 5 or bigger. So about 44 years. So if I added 44 years to my starting year, which was 1999, that gave me the year 2043. All right, number 17. This one is asking me for all vertical, horizontal, and oblique asymptotes. And this one actually, I kind of gave you a bad one, and I'm going to talk about why in a second. But the one on the test is set up pretty similarly to this. It gives you a rational function. My vertical asymptote is always going to be when the denominator is 0, so that was just at 2. My horizontal asymptote, that's that rule where you have to check these leading coefficients, or the degree, and then if it's a certain situation, you'd have to check the leading coefficients. In this one, I have an x cubed, though, over an x. So I have a degree of 3 over a degree of 1. Because the top was greater than the bottom, there are no horizontal asymptotes, but I can check for oblique asymptotes. Now this is where the weird part came in on my particular problem. I divided it, which is what you should do. So take your numerator, divide it by your denominator, and basically what you get here is your function, your asymptote, your oblique asymptote. It's the equation for that line. And then your remainder doesn't matter. It's not a big deal. Well, this one ended up with a remainder of 0, and the function I came up with was a quadratic. Typically what you come up with is a linear, so that asymptote looks like that. This one did not end up that way. So sometimes they call these just quadratic asymptotes or cubic asymptotes instead of an oblique asymptote. On the test, I believe yours will come out just as a linear, so you won't have to worry about that. I really should call this a QA or a quadratic asymptote because that's how it came out. But usually that would just be maybe an x minus 4 or something easy like that. Okay, number 18, find the average rate of change. I guess I didn't box in my answers there, so all of those are my answers. Find the average rate of change of the function. So here's what you should do in this case. I would plug in these values to the actual function. So that's what I did over here. I said, what is f of negative 2 and what is f of 1? Okay, so then I got those answers. Then this setup right here is your, how do I write this? F of x2 minus f of x1 all over x2 minus x1. So I'm doing slope. That's what rate of change is. It's a slope. So I'm doing like y2 minus y1 over x2 minus x1. That's exactly what this is. So I did 2 minus 11 over 1 minus negative 2, which really means plus 2. Now let's say that I switched these and I said, you know what? I am going to do 11 minus 2 over negative 2 minus 1. I'm still going to get the same answer, guys. It doesn't matter which way you do it, so don't get caught up on that. Just be consistent. So if you put your x2 value first, so let's say I put x2 first like I did right here, that means my x2 value down here has to go first. So just make sure that you're consistent. All right, number 19, they wanted me to solve f of x equals 2. So I think some people might get confused on this one that f of x equals 2. Well, that means this right here is 2. So they're just saying set this equal to this. So that equals that. Well, then I needed it to equal 0. So I minus 2, got it to look like that. And then this one was factorable, which was really nice. If it's not factorable, use quadratic formula. So there's my 2 answers, nice and pretty. This one, same thing, get that equal to 0. If it's not factorable, use quadratic formula, which I had to do. In this case, it came out with a negative square root, so I did what I did on a previous problem earlier, and I simplified it out just in that exact same way. And then I wrote it in my A plus BI format. Okay, number 21, I apologize. This one was so not legible. You can't read that very well. So I promise I won't put any on the test that you can't read very well. This one I copied and pasted it from the review that they gave me, and this is just how it came out when I printed it. So I apologize for that. But what I do on problems like this is I look for my leading coefficient first. In this case, I'm going up on my ends, right? My end behavior is that it's going towards infinity. Okay, so that tells me that I need a positive leading coefficient. So that took out C and E and F for me. If this had looked this way, then that would tell me I need negative as my leading coefficient. Okay, so that got me down to 3 choices. So I'm down to 50-50 chance, or not 50-50, but I was able to eliminate 50% of my choices. So now I have 3 options to go between, and I would first look and see where are my zeros. Again, this was kind of difficult to see, but I will tell you that these were marked by 5s. So that's a -5, this is -10, this one was 5, this is +10. So that means I had one at -6. So I wrote it out like this. Let me get rid of these for a second. So I wrote it out as -6, and negative 3 was this one, positive 1 was this one, and positive 5 was this one. Then I went through and I remembered it's x minus c. When I write it into an actual function, it's x minus c. So I changed my signs and put an x in front. So these are the factors I should have. So I wrote out those factors, looked at all of these, and that for me eliminated this one because that was an x plus 5. I don't have an x plus 5 anywhere. So now I'm down to a 50-50 chance. And this is where you just have to have some common knowledge about functions. So this one, notice how these go through the x-axis and these touch it and go back down. Touch it and go back up. In this case, this one went through. So this one and this one touched it and then went back the other direction. Those are the ones, ooh, I'm a little out of focus here. There we go. Those are the ones that should be squared. So at negative 3, this one should be squared, which in answer choice A it was. At 5, so my x minus 5, that should be squared. So these two cases right here are those weird ones. So that's how answer choice A was at. All right, number 22. What is the inverse? So I wrote this out with a y instead of an f of x, and then I switched my variables, and then I solved. So once I got here, I needed to write it as e to some exponent, which I did, and then I just solved for y. Once I did that, I just rewrote it as f to the negative 1, or the inverse of f, and I wrote it out like that. This one asked me to divide, so that was long division. I wrote it out as here's my function for the division part, and then this was my remainder. That's on the exam. That's how they will ask you to list your answer. This one I factored. So this was e to the 2x, and this was e to the x. So I knew if I took e to the x times e to the x, I get e to the 2x. So I was able to just factor this like a normal problem as if this was just x and x for x squared. And then that gave me two options. One of them came out as the natural log of 3. One came out as the natural log of negative 5. That is not okay. A negative is not. So that means my only answer is the natural log of 3. This one, okay, so the leading coefficient test means this. The leading coefficient tells me if it's positive or negative, and then that tells me if I start going to infinity or negative infinity. Same thing with my end. Negative or positive. Because this is an even exponent, these will be the same. I will either both end downward or both end upward. So since this was negative, they both end downward. And then I knew that I needed to have 1, 2, 3, 4, 5, 6, 7, 8 zeros in between. So this is kind of what it would look like. But really the idea is I had to know that as x is approaching negative infinity, and as x is approaching positive infinity. So I need to write these two statements right away. Then this is happening to my y value. And in this case, they were both going to negative infinity. This one, I added my 3 first, then I wrote this as a log. And then that saved me some time. They wanted me to write it as a log with base 5, so that's what I did. The last thing I did, when I added 2 to both sides, a lot of times people want to write that as log base 5 of 12 plus 2, like that, equals x. I would not do this because then some people might think you mean log base 5 of 14, which is not what we mean. So I put the 2 up front just to avoid that confusion. All right, this one, similar to another problem we did earlier, I'm having to take g of f over g. So I found f over g first and wrote that out. Then I plugged that into my g function. So this plugged in right there for that x. So I wrote that squared and then minus 9. And then I just, the only thing that I really need to know from there for the domain is what can it not be? It can't be 3 and it can't be negative 3 because this denominator would be 0 in those cases. So that means I had to do open parentheses for my negative 3 and for my positive 3, but everything else was included. So I was able to write from negative infinity all the way up to negative 3, but don't include it. From negative 3 to 3, but don't include it. and then from 3 to infinity. Okay, this one, it's probably the easiest question on the test if you know how to do it. If it's a one-to-one function and it has a domain and a range of these things, find the domain of its inverse. The inverse is going to have the domain, a domain of what the range is on the other function. So it's just whatever the range is. If they had asked me for the range, I would have given them the domain because it's the inverse. All right, 29. This one seems super complicated, but if you know what to do, it's not too bad. So this f of x right here, f of x plus 3, they told me that my range was from 3 up to 12, so for that function. So I really don't care what this value is. I just want to know what my lowest and what my highest values are. So my lowest value for this was 3. My highest value for this was 12. Then I just used this information around it to solve. So 2 times 3 was 6, minus 8 was a negative 2. 2 times 12 was 24, minus an 8 was 16. So that made my new range from negative 2 up to 16. So this to this. I feel like a lot of people will miss this one if they don't watch the video. So maybe point that out to your friends if you're a nice friend and you're watching this. All right, last one, number 30. Solve the compound equality. I think this is a pretty easy one. So I subtracted 4 from both sides, and then I divided by negative 3. Don't forget to flip your signs. That gave me these two situations. So just be careful with how you interpret that. So that made my x values anywhere between negative 7 and 4, including negative 7, but not including 4.